Hello everyone, my name is Abhishek and welcome back to my channel. So today we'll be talking about Linux operating system and basics of shell scripting. So if you haven't watched our previous videos on DevOps, so just to let you know that we are doing a complete free DevOps course. It will be a 45 to 40 to 45 days of DevOps course where we'll be talking about most of the DevOps things, and our aim with this DevOps course is to make a person with zero DevOps knowledge hero in DevOps. So if you haven't watched those videos, there is a playlist on my channel called DevOps Zero to Hero. I would highly recommend you to watch the previous videos before jumping onto this video. Perfect. So if you move to the agenda for the day, that is Linux operating system and the basics of shell scripting. Firstly, what is a operating system, right? Before you understand the concept of Linux operating system, you should know the basics of operating system or what is an operating system. So just try to understand with a practical example. Let's say you have a laptop or you purchased a Raspberry Pi or any other server. Okay. So what are the key components of any server, right? The key components is that you are purchasing hardware. I understand you get a lot of fancy things like your display, you get other things, mouse, keyboard, and all the other things that you are purchasing. But essentially, you are purchasing hardware that is nothing but your CPU, RAM, and IO, right? Or hard disk. So you are purchasing these things. And what you do once you purchase the hardware is you try to use some softwares on top of your hardware. Okay, let's say you purchased a laptop. What would be your interest? Your interest is to make use of some softwares, whether you're using this for gaming, okay, or let's say you are a DevOps engineer, so you must be using some applications like Jenkins, or you must be using some office related stuff, or as a student you might want to learn something like Java or Python. So you are essentially running some softwares, right? This is what you are doing. So you have a software application that you want to run against the hardware that you purchased. Okay, but you can't directly do it. Okay, let's say as a user you install Jenkins and you want to execute your Jenkins pipeline. Your Jenkins can directly not I mean it cannot directly talk to you, the CPU or RAM or the IO. There has to be a medium between your software and hardware, that is nothing but your operating system. Okay, so what is the operating system? Operating system is something that acts as a bridge between your software and hardware. So it drives as a medium for the communication between your software and hardware. That is the definition of your operating system. Okay, so whether it is a Linux operating system, whether it is a Windows operating system or anything. So today when you purchase your laptop, let's say you purchase the Dell laptop. Okay, so what Dell does is it sells you the hardware. Okay, and on top of the hardware, what is it doing? It is installing a operating system and it is giving it to you. So you purchase the Dell laptop which comes with the CPU, RAM, IO, and along with that what Dell is doing is it is installing Windows operating system. Okay, so that is the reason why you are able to directly deploy any application or install any application, and your application is able to process the requests that are coming from the user, that is you. So as a user, what you are trying to do is you are installing an application and your application is talking to the operating system and your operating system is talking to your hardware and vice versa, right? Your hardware is again talking to your operating system. Your operating system gives back the information to the application and your application gives back the information to you. So this is the process. So the communication happens in this way. Firstly, as a user, you are installing some application on your laptop and your laptop or your server. Okay, just for your easy understanding, I'm mentioning it as a laptop, but always understand it as a server. So as a user, you installed application or software on your server, and your server is giving the response or sorry giving the request to your operating system, and your operating system is sending the request to your hardware for CPU usage or RAM usage or anything. Again, your operating system is giving the response back to your your hardware is giving the response back to your operating system. From operating system it goes to your software or your application, and finally it reaches the user. So this is the life cycle, and this is where your operating system plays the key role. You must have your applications ready, you must have your hardware ready, but without operating system nothing happens. So that's why it's a core, or it's a heart of everything. Again, depending upon your comfort, whether you're using a Apple, like let's say that you purchased a Apple laptop or your Mac laptop, so it comes with your Mac operating system. If you purchase Dell laptop, by default most of the times it comes with your Windows operating system. You're purchasing ThinkPad or something, the Linux version of it, so it comes with your Linux operating system. So depending upon the user or depending upon the vendor, they come with your own operating systems. But why Linux is very popular? But if you just think for a minute, as a student or as a kid, most of the times you are familiar with Windows operating system. But once you move to your software journey, you see that Linux is used everywhere, whether in your production system, staging, developer environments, everything is deployed. All the applications are deployed and tested on your Linux operating system. I agree that there are Windows as well, like, but 90 to 80% of the times you test on Linux operating system and you also deploy on Linux operating system. Let's try to understand why. Okay, so there are very good reasons why Linux is very popular. First and foremost reason is Linux is a free operating system. Okay, unlike Windows, Windows is a proprietary operating system. You must know that it's a proprietary operating system provided by Windows, right? Sorry, Microsoft. Whereas Linux is a freeware, or it's a open source software. So today anybody can create Unix like operating systems, that is Linux like operating systems. And again, one of the key reasons is Linux is very secure. For example, you have a Linux laptop and you have a Windows laptop, you don't even have to install any kind of antiviruses. For on your Windows laptop you must have installed McAfee or any other things like antivirus softwares, right? Anti-malware softwares. But whereas you Linux, you don't have to install any kind of antivirus. It is by default very secure. I'm not saying that it is 100% secure, but most of the times your Linux operating system is a secure software, and it contain a lot of distributions. Like, today you have many distributions like CentOS, you have distributions like Ubuntu, you have distributions like Red Hat, and a lot of other things, right? But if you talk about the free distributions, you have popular ones like Ubuntu, CentOS. People also use Alpine, Debian. So different kinds of distributions are provided. So you can, depending upon your comfort, you can use any distributions. And finally, one of the most important things for any application to run on your production systems is it has to be very fast. If your operating system is slow, because your operating system is heart of everything, like whenever a user is trying to send a request, let's say you are trying to access amazon.com, you are trying to access Netflix. So if your operating system itself is very slow, then it doesn't matter, right? Whether your application, you must have used advanced concept like multi-threading or any other things in your application, but if your operating system is not capable of taking these requests, then it's of no use. So that's why people always prefer fast running operating systems, or the operating systems which are not crashed or which are not slow in their production systems. That's one of the key reasons why Linux is used as an operating system in production systems. So it is very fast, it is very secure, and it is also free in nature. So what are the things that you want, right? When something comes for free, when something is very secure and fast, then that's a bliss, right? That's a blessing. So that's why people use Linux operating system over Windows. Okay, so if somebody asks you what is the difference between Linux and Windows, so this is something that you answer. Or why Linux is most widely used when compared to other operating system, these are some of the reasons. Now let's try to take couple of minutes to understand the architecture of it. Okay, so I'll not bore you, or I'll not go into the details of the Linux operator architecture, because it's very complicated, and it's not even for me to explain the entire Linux operating system, even if I take 1 2 hours, it's not easy to understand or easy to explain. So that's why what I'll do is I'll try to keep it as crisp as possible or as simple as possible. So let's try to break it down to make it easy. Okay. So let's say this is your operating system, OS. So firstly, the heart of your Linux operating system is your kernel. Okay. And on top of your kernel, you have something called as your system libraries. Don't worry, I'll explain them in detail. And on top of it, you have some of the things like you have your compilers, you have your user processes, and you have some system related softwares. Even for your Windows, you have some system related softwares, right? So similarly, even for Linux, you have some system related software. So whenever you are installing Linux, let's say you install Linux on your laptop, so these are the things that you are installing. Okay, so because these are the fundamentals of your operating system. So firstly, you need to understand what is a kernel. So kernel is heart of your Linux operating system. Why? Because the responsibility of kernel is to establish a communication between your hardware and your software. Like I mentioned, so there is a user. Okay, the user is installing an application, which is a software, and then there is a hardware that is nothing but your CPU, RAM, IO. So operating system is responsible for basically uh, cascading your request that is from your software to hardware. So who takes the responsibility? Like there should be a component in your operating system which is taking this responsibility, right? So that component is nothing but your kernel. So that's why kernel is again here heart of your operating system. So there are some primary responsibilities of kernel that you have to understand. That is, for CPU it does okay, let's try to put it in this way. There are four important aspects of your kernel. Even if somebody is asking in an interview what is a kernel in an operating system, you can just say that kernel has four primary responsibilities. It's a heart of any operating system which does device management. Okay, kernel is responsible for memory management, then it is responsible for your process management, and finally it is responsible for handling your system calls. Okay, for any operating system, these are the key aspects and that are handled by your kernel. One is device management, memory management, process management, and handling the system related calls. After that, you have system libraries, right? uh, like as I mentioned, you can also take example of kernel modules and the other things, but let's try to keep it very simple. So after the kernel, you have system libraries. And what you have in system libraries? So system libraries are basically responsible for performing a task. Let's say user is trying to perform a task. So it comes from your system libraries and then it goes to your kernel. So each operating system has their own supported kind of these system libraries. So let's say you are installing a Debian distribution, or you are installing a different kind of distribution like your CentOS or Fedora. Your system libraries might differ slightly, but again, most of the times the concept of the system libraries is the same. If you want to take a example of a system library, you can try to understand, like you have your libc, right? So libc is one of the system library, just for your understanding. So there are other system libraries like the graphical gnu or the other things, but okay, after that you have the final stage where you have compilers, user process, and system softwares. So compilers, coming to the compilers, so like let's say you want to run Java application, or Java, or you want to run Python, or you want to run any other kind of your software. So your operating system has to compile this code, right? Your application or these kind of things. So for that reason, you have compilers, user processes, and some kind of system softwares. Even if you're using a Windows laptop, you are aware of your system softwares that you have. So these are the fundamentals of any operating system. Like definitely I'm not going to the details of each of these things, because even for me to explain, like even when I'm trying to explain these things, I'm trying to keep it as crisp as possible. That's why I'm taking some time while explaining it, because I don't want to complicate these things, and explaining these things in like 30 to 40 minutes of session is technically not possible. But you have to understand the breadth of the concepts. Like even in this 40 to 45 days of DevOps journey, if we spend 2 to 3 days in just understanding the kernel, or if we spend 2 to 3 days in understanding the operating system, that will be of no use. You have to understand the breadth of the knowledge of all the different kinds of concepts that are available in DevOps or most widely used in DevOps. And once you understand the breadth of it, you can start giving your interviews. And during your interviews, you can go into the depth of each and every tool. For example, if I'm explaining you about the configuration management, you have to understand about configuration management, but you don't have to spend 10 days, 15 days in just understanding different tools that are available in configuration management. Like don't learn Ansible, Puppet, Chef and everything. Just learn one thing, start with your interviews, and then once you're comfortable with your DevOps journey, then probably you can understand, okay, what is Puppet, why Puppet is different from Ansible. For now, just restrict to one thing. So even today, I'm just explaining you the core concepts of operating system, but not going into the details of kernel, not going to the details of system libraries, because that will be very complicating. Now, so what did we learn till now? We understood what is an operating system. After that, we try to understand what is the definition of an operating system, why operating system is useful. Basically, it is useful for establishing a communication between your hardware and your software. Whenever a user sends a request, it has to go from your software to your operating system to your hardware. Finally, the response is also received back in the same way. And then we try to see why Linux is a very popular operating system, and why Windows or other operating systems are not used in your production systems, because of the free, secure, and the fast nature of your Linux operating system. And finally, we also try to understand the architecture of your Linux operating system. So now let's move ahead and try to understand the fundamentals of your shell scripting. Okay. So today we'll not go into the details of shell scripting, but we will only take a look at the fundamentals of shell scripting. So because you understood what is Linux operating system, why you have to use something like a shell scripting? Basically, what is shell? Shell is a way that you talk to your operating system. Let's say you want to create a file. What do you do in your Windows? So Windows has a very good graphical user interface, but most of the times when you're working in your software organizations, you don't have a graphical user interface for your servers. So if you have issue on your production server, you don't have a graphical user interface for you to navigate through the folders to understand what is issue. So you have to do it through some uh, command line way. Okay, so this command line way through which you talk to your operating system are nothing but your shell commands. Okay, so in Linux, the way that you talk to your operating system is using your shell commands. So shell is most of the times, like 99.9% of the times, your servers that you're using on your production or your dev or staging environments default come with the shell environment. So you can, if you are aware of the shell commands, you can directly talk to your Linux operating system. And these commands are common across different distributions, whether you are using CentOS, whether you are using Fedora, or whether you are using Debian or Ubuntu. So these shell commands that we are going to talk, or which we use as a DevOps engineer, are mostly common across different distributions and different yeah, just the different distributions, not operating systems. So that's why today we'll try to see what are some of the popular shell commands. So again, just to give you an example, if you want to create a file on your Windows, what you would do is you would navigate through your graphical user interface. That is, you go to your laptop making use of your mouse or cursor, you navigate through the different folders. But on a Linux operating system, that's not possible, because most of the times your graphical user interface GUI is not installed, because it comes with some weight, right? If you want to install graphical user interface, again your operating system or your servers would become heavy. So that's why on your production systems we don't use graphical interface, and most of the times we make use of the shell commands to talk to the distribution, or to create files or to create anything in your operating system. So let me just stop sharing. And in the previous class, we already understood how to create a virtual machine on your AWS, right? Whether through the command line or whether through the AWS CLI. We already talked how to create this server. So now let me make use of one of the server that I created in the previous class and show you some of the basic commands of shell scripting. So I'll stop sharing here and share my screen with the stop sharing, and let me share my terminal. So you can use any terminal, whether you want to use putty, like I explained in the previous classes, whether you want to use mobile term or any other thing, that's totally fine. You can use anything. Yep. So let me share my screen again here. Okay, cool. So what I've done is I am for now I'm using a Mac laptop, but I've installed Bash in it. By default, it comes with SH, so you can use ZSH or you can use Bash. So I've installed Bash. Like I most of the times recommend, Bash is one of the popular ones and most widely used. So instead of learning KSH, instead of learning SH, just learn Bash, and you can use this scripting even once you start your software journey. And even in our DevOps zero to hero DevOps journey, we'll be learning about Bash only. So I have, like I mentioned, I have this one here. The Just give me a second for me to pull the. Okay, I got hold of my IP address of the newly created AWS instance in the previous class. So this is the command I'll use to log in. So if you just want to understand one more time, so this is the key value pair that we just created, I mean, in the previous class, and using the identity file, that is the key value pair. What we do is we make use of the public IP of the EC2 instance to log into the instance. So we created a Ubuntu related image in the last class. So that's why the user that comes by default is something that I already know, that is the Ubuntu. So that's why I use the command ssh-i identity file Ubuntu at the rate public IP address. Perfect. So this is the server. It has Linux operating system installed. That is nothing but your Ubuntu distribution. So even in Linux operating system, you have different distributions. Most of the times we use Ubuntu or CentOS. Distributions are nothing but the vendors that are providing this Linux operating system, right? So Red Hat is a vendor that provides Linux operating system using Red Hat. CentOS is one, Fedora is one, Ubuntu, Debian, different vendors provide Linux operating system. You can make use of anything. Ubuntu is most widely used. So what is the command? First of all, you got into this one, but you don't know how to navigate from one place to another place, right? If it is Windows, what you would do, you would directly make use of your mouse. You would see what are the files and folders that are present. But on your Linux platform, if you want to see what are the different files and folders that are present here, the command that you make use is ls. So by using ls, you try to understand what are the files and folders. Ls is nothing but list. Okay, so using ls command, you list the files and folders. But if you see here, it is showing the files and folders in this particular directory, right? But I want to see the files and folders everywhere. But for that, I need to understand where I am currently. Again, if you are on Windows, what you would do, you would right click and see what is your current location. But everything in Linux has to be done through some commands. For that, what is the command that you use is pwd. So pwd stands for present working directory. So always, once you start logging into your server, firstly make use of the pwd command to understand what is your present working directory. So here it says that I am in the /home/ubuntu working directory. Now I can change this present working directory by using the cd command. So using cd, that is change directory. Okay. So again, always try to compare with the operations that you are doing on your Windows machine if you are very used to, just to understand how to correlate, right? If you are, for example, you want to move from C directory to the D directory in your Windows, what you will do, you will make use of the cursor and click on the back, you do back click and then go to the D directory. But In Linux, it's not possible because there is no graphical user interface most of the times. So that's why firstly you would do pwd to understand where you are currently, and using ls you understand what are the files and folders that are available in the directory. And let's say you want to move from slash ubuntu to bundle directory. So for that, what you will do is you will make use of the cd command. Cd stands for change directory. Cd bundle. And once you do cd bundle, again if you do pwd, you can clearly see that your present working directory has changed. So your present working directory is slash home slash ubuntu slash bundle. Okay. So just to repeat, always once you log in to your uh, linux software or linux system, what you would do is firstly you execute the command called pwd to understand what is your present working directory. And once you understand your present working directory, you need to do the ls command to list the files and directories. Okay, so inside this present working directory, I have few files or folders as well. So for me to understand, or to just see, like let's say somebody asks you what are the files and folders that are present in bundle directory. So you make use of the ls command to list the files as well as folders. Once you list these files and folders, let's say I want to move to a directory called bundle. So what I'll do is I'll make use of the cd command to change the directory. Okay, so using cd, I'll go to the bundle folder, which I am currently already in. Or let's say there is a test folder. So what I can do, cd test. Once doing it, again if I click on pwd, you'll see the present working directory has changed. If you want to go back, okay, like let's say you came here and now you just want to go back, instead of giving the complete path, what you can simply do is you can say cd space dot dot. So what happens when you do cd space dot dot is you go back to one directory. Let's say you want to go back to two directories. Okay, so what you say is cd dot dot slash dot dot. By doing that, now you are in just the home directory. And if you want to go to two directories more, or two directories in depth, what you can do is cd ubuntu slash bundle. Okay, so this is how you move from one directory to another directory. And if you want to do with multiple, like you want to go back to multiple directories or go ahead of multiple directories, you can make use of this slash operator. Perfect. So just in 1 minute of time, we learned about three different commands, that is pwd, cd, ls. So we learned about these things, right? Now, let's say I want to list all the files and folders with timestamp, who is owner of the file, and other information like is it a file or a directory. So you can make use of this one simple command, that is ls hyphen ltr. Okay, ls minus ltr. So what does this ls minus ltr does is it provides you the information, like if it is starting with d, that means that it is a directory. If it is not starting with d, that means that it is a file. So if you see here, this is a directory, this is a directory, test is a directory, metadata is a directory, like manifest is a directory, bundle is a directory. And if it doesn't start with d, that means that it's a file. After that, you have information of who is the owner of the file, which group owns this file, what is the content, like what is the size of the contents inside this file. And after that, you also have information like when is this file created, the timestamp of it, and what is the name of the file or the folder. So if you want to just list the files and folders, you can use ls command. But ls supports advanced, that is using ls minus ltr, you can list the files and folders with its properties, that is who is the owner, who is the group owner, or what is it a file and the folder. And you also provide get the information that what are the permissions of it, and what is the size of it, and the timestamp, using the ls minus ltr. So these are some of the basics, right? And after this, you might want to create a file. Okay, so to create a file, you can simply use the touch command. So using touch command, you can create a file. But like let's say touch space Abhishek. So now what happens is a file called Abhishek is created, and to see if this file is created or not, you can use again ls command, and you'll see a new file called Abhishek. Okay, but if you just want to create a file, touch is fine. Most of the times you want to create a file and you want to write contents inside this file. So for that, we use the vi command. So using vi, you can not only create a file, but you can create a file and write inside the file. So vi space, let's say test. So a file called, see here, a new file is being created with name vi, sorry, with name test, and you can also start writing into the file. But to write content inside a Linux file, okay, or file in a Linux, it's not straightforward, because when you open a file, Linux will ask you, do you want to read the file, do you want to write content into the file? So using escape, okay, always once you enter a file, click on escape and tell Linux that I want to write content inside the file. So click on I. By clicking on I, you will move to the insert mode, and then you can start writing into the file. Hi, I'm Abhishek. Okay, and using again escape, you have to use this called colon wq to save the file. Okay, so now you wrote contents inside this file, and using cat you can basically print the file. Now if you feel that I am moving too fast, don't worry, I have already created a very good video that covers all the basics of shell scripting. I'll put the link in the description, don't worry. It's almost like 90 minutes of video, or sorry, 80 minutes of video, where we covered all the fundamentals of shell, and again we created one more video that is of 1 hour to cover some intermediate concepts on shell. So totally we have 2.5 hours content on my channel that only talks about this shell commands, how to write some simple shell scripts. So if you haven't followed any of these things right now, don't worry. I'll put the links in the description. You can watch both of those videos where I covered most of the concepts of shell commands, like from basics to the intermediate level of shell commands. So also we did a shell scripting interview questions video. So watch those videos, and you'll get very familiar with the shell command, shell concepts. And tomorrow's class we'll talk about some advanced topics, where we'll take a look at one real-time DevOps project. So you might be learning all of these shell commands, but if you don't understand where are these practically used, so that will be a problem, right? So that's why what I'll do is I'll make a video where I'll talk about a real-time DevOps project using shell scripting, why shell scripting is used in an organization, just for one example. And with that, you can understand, okay, so this is a real-time use case of shell scripting in DevOps. Probably you can enhance, or you can think of other alternatives, and you can create your own projects, and you can put them on your resumes. Perfect. So this is something, and then you have some other commands, like for creating directories, you have a command called mkdir. Using mkdir, you can create directory, and for removing the files, you have command like rm. Okay, so using rm, you can remove a file, and using rm minus r, you can remove a directory. So these are some of the commands that we usually use as part of day-to-day life. Okay, so it says folder already exists. Let's say I do mkdir and call it something called as Abhishek1. So it creates a directory called Abhishek, Abhishek1. And then if I want to remove the directory that I just created, I can use rm minus r Abhishek1. So these are some of the popular commands that people use it in day-to-day basis. But apart from this, so this is about creating a file, writing a file, reading a file, and all of these things, right? But let's say you want to log into a Linux machine, and you want to check the CPU, memory, or the performance of your machine completely, which is very important, right? So let's say that you're using a Windows machine, and in your Windows machine, all of a sudden you realize that your Windows machine, all the CPU is used or RAM is used. So how do you check? Basically, you go to your system properties, and you'll see what is the RAM size, and then you will go to Task Manager, and you will see how much RAM is used. You'll compare both of these things, right? So in your system properties, you understood that your laptop is of 8 GB RAM, and in your task manager you realize that okay, 7 GB is already used. So similarly, let's say you want to do the same things in your Linux. So for that, you do it only through your shell commands. Okay, so what are the shell commands that you'll use here is for looking into the memory. You use a command called free. So using free, for better readability, what you can do is you can do free minus mg, sorry. So using free -g, what you can do is you can understand what is the memory of your laptop, that is, or your server, and using nproc. Using nproc, you can understand what are the CPUs, number of CPUs that are, because this is a basic EC2 instance that I just created, right? So it says that it only comes with one CPU. We know, but because we are using a free EC2 instance, right? So that's why it just has one CPU. Now, and finally, you want to understand what is the disk size. So for that, you have a command called df minus h. So using df minus h, you can understand what is the disk size. So 24 percentage I already used. So it comes with 5.8 GB and 1.9 GB I already used. So just like, sorry, 7.6 GB is the total size. 1.9 GB is something that I used, and 5.8 is available. So 24 percentage of this is something that I used. If you want to see all of these things at one place, there is a very popular command that is called top. So using top, you can get the complete information. So it's like a memory, CPU, and disk, everything. Like you can monitor everything from one place, that is using top. So it says, like, what is the CPU percentage that is used, what is the memory percentage that is used. So this is a very popular interview question. That is, what is the command that you will use to manage your memory, CPU, or look into the details of it. So the answer is using the top command. And individually, if you want to do, you can use, for memory, you can use the free command. Free is the command name. For CPU, you can use a command called nproc. Okay. And for disk, you can use a command called df. So all of these commands, if you want to look into one place, that is using the top command. So these are some of the popular shell commands that you use day-to-day basis. We looked into creating a file, creating a folder, removing files, writing into a file, reading a file, and listing a file, how to look into the permissions of a file, right? And finally, we also looked into some of the processing or management related commands, that is df to look into the disk file size, and memory using free command, and CPU using the nproc command. And for the whole management, we can use the top command. So we looked into all of these things, right? And if you have still more questions, or if you are eager to learn many more shell commands, so like I mentioned, I created 3 videos on my channel, and there is also playlist called shell scripting, I guess. So I'll put all of the links in the description. So once you watch these videos, at least watch the intermediate level video where I covered a lot of shell commands before we move to the tomorrow's topic, because in tomorrow we will see a real-time shell scripting DevOps project. Perfect. I hope you enjoy the video where we understood the concepts of operating system, basics of shell scripting, and everything. If you feel that this video was useful, click on the like button. If you have any feedback for me, whether it's positive or negative, put that feedback in the comment section. So I'll make sure to take your feedback and improve in the future videos. And finally, if somebody is willing to learn DevOps and is not a subscriber or a viewer of our channel, please try to share this video with your friends and family. And if you haven't subscribed, please subscribe to my channel. I'll see you in the next video. Take care.